Okay, Algebra 2 students, this is still the statistics review, and we are now on page 3. Number 6 says the number of texts sent by an American teenager is normally distributed. An American teenager sends an average of 3,300 text messages per month with a standard deviation of 460 texts. What is the probability a teenager will send between 2,840 and 3,760 text messages? The easiest way to do this problem is on your calculator. I'm going to write down what we're going to press, and then we will do that. So you need to start with second, and then vars, and you're going to choose normal CDF. Okay, now at that point, some screens will give you just an open parentheses, and you need to put these numbers in on your own. Some screens will prompt you for what numbers to put in. That's a little bit easier. But if they don't prompt you, here's the numbers that you want. You want the lower bound for the data you're asking about. That would be this one. And then you want upper, comma, upper bound. That would be this one. Then you want the mean, and let's see, average is the mean, so that's here. So 3,000, well, I'm going to write mean, and then you know that to put that there. And then finally, you want the standard deviation. And the standard deviation is this. Alright, so in your calculator specifically, you'll still press second vars normal CDF. Your lower is 2840. Your upper is 3,760. Your mean is 3,300. And your standard deviation is 460. And we still are pressing all of this, so let's give it a try. Okay, clear. Second vars. Normal CDF is choice 2. Lower. So our lower is 2840. And, oops, I don't want to close those yet. Comma, upper 3760. 3300. And 460. Okay, so this tells me that I have a 68.3% chance that the data will fall between those two numbers. Alright, what is the probability that the teenager will send more than 4,000 text messages? So we're still going to do second vars normal CDF. So for your lower bound, you want 4,000. But for your upper bound, you want infinity. And there's no infinity button on the calculator, so we're going to type a really big number, which is 1E99. The mean is same mean, 3,300, and the standard deviation is still 460. Alright, so let's try practicing that one. Okay, second vars, choice 2, normal CDF, 400. Oops, didn't like that. normal CDF. Oh, that should be 4,000. Okay, let's change it over here first. Okay, so I need another 0, 4,000. Alright, so put the 0 here, the comma, the 1, and second comma, that gives me the E, 99, and the comma, 3300, comma, 460. Okay, so it looks like it's only a 6.4% chance of being more than 4,000 texts. What is the probability a teenager will send less than 2,000 text messages? So we're going to still do second vars normal CDF, and my lower bound is negative infinity, so it'll be negative 1E99. My upper bound is going to be 2,000. My mean and my standard deviation should be the same from the original problem. So mean of 3,300 and standard deviation of 460. Alright, so second vars normal CDF, negative 1E, so press second comma to get the E, 2,000. Oops, I think I went too far. Darn, I'm going to start over. Second vars normal CDF, negative 1, second comma, that gets you the E, 99, comma, 2,000, comma, 3300, comma, 460, and then close it. Okay, so this seems quite small. If you move your decimal over 2 places, that's less than 1%. It's 0.236%. All right, what range of messages would be within 1 standard deviation of the mean? Well, let's see, the mean was 3,300. So I can add and I can subtract 460 from that. So I'm going to do plus 460, and I'm going to do 3,300 minus 460, and see what we have left. So it looks like if we subtract, we get 2,840. So we have between 2,840 and 3,760 messages. Alright, so Sarah's trying to remember the passcode on her phone. It's 2 letters and 2 numbers, and so she's going to keep trying to see if she can figure this out. So let's see, 2 letters and then 2 numbers. It does not say anything about not being able to use something twice, so we're going to assume we can use these twice. So you have 26 choices for the first letter and still 26 for the second letter. And then for the digit, it could be 0 through 9, so we have 10 choices for the first digit and 10 for the other. You're going to multiply these, 1, 2, 3, 4, multiply them all, and you should get 67,600 ways you could sell a car. Nope, that's not a car, that's a passcode on her phone. So that would take her a long time to figure out. Alright, we've got 1 page left. Let's turn the page. At Max's sandwich shop, they have 10 different meats, 5 cheeses, and 3 types of bread. How many different sandwiches can be made? Well, we're assuming we're going to take 1 from each group. So we have 10 choices for the meat, 5 choices for the cheese, and 3 choices for bread. And you want to multiply those 3 and you get 150 different sandwiches. How many different starting lineups of 11 players can be chosen from a roster of 16 players if every player can play any position? So if they can choose any position, then the order doesn't matter, and it's going to be a combination. So it would be 16, C, 11. We're choosing 11 out of 16. On the calculator, we want to look at the math button. So we said 16 first, math, go over to probability, and you want the C, which is number 3, and you're choosing 11. Alright, so that one looks like 4,368. Okay, 10 students are in a race. First, second, and third will win medals, so the order does matter. If there are 10 runners and you're only going to give medals to 3, let's figure this out. It's 10 P3. And then you're going to use your formula or your calculator. So on the calculator, we would type, let's see if I can move it over, 10. And P is math, go over to probability, and go down 1, and then 3. So I have 720. Alright, and now some vocabulary. Ahmed's test score for chemistry has a z-score of 0.5 compared to all of the other students in his class. So what that tells us is it's a positive number, so it's above the mean, but it's not quite 1 above the mean, so it's not that far above the mean. So Ahmed's score is a little above the average. If the population data has a normal probability distribution, what conditions must be true? Well, in that case, the mean would have to be the same as the median. And it will also end up being the same as the mode. The difference between a permutation and a combination. In the permutation, order matters. In the combination, order does not matter. How can you find the median if there are an even number of values? Well, you're going to take the 2 numbers in the middle and you're going to average them. So I'm writing average the 2 numbers in the middle. Alright, and the z-score actually measures standard deviations. So if you think about your bell curve, if you have a z-score of positive 1, then you are 1 standard deviation above the median. Let's write that down then. The z-score measures how far, let's erase that word, how far you are from the median. Okay. Do we have one more? Let's double check. No, I think we're done. Okay, so congratulations, keep studying, and good luck on your quest.